Union Switch and Signal developed the H5 Searchlight around 1945. It was an improvement over the company's earlier and similar H2 signal. The Santa Fe was an early convert as they were rapidly expanding their traffic control system after World War II. Thousands of signals and tens of thousands of miles of wire and poles were installed along the right-of-way. The many wires were used to transmit pulse codes from a central dispatcher's office, usually at the division level, to each field location, typically called an OS section. The field location received the command, executed the dispatcher's instruction, and responded back to the office location confirming the instruction was properly implemented. These commands were interlocked by hundreds of mechanical relays to ensure no indication or instruction could be executed improperly. For example, the dispatcher could not throw a switch if a train was in the OS section. Here is a TCS board I built from component salvage from a prototype TCS machine I bought from the Santa Fe in Amarillo, Texas. It was fully operational on my HO scale layout in Dallas during the mid-2000s. According to railroad signal rules, the color of the signal is called the aspect. What it means to the train crew is the indication. In other words, a steady red signal, aspect, means stop indication. Around 2006, a Santa Fe signal maintainer gave me this perfect example of a US&S H5 Searchlight signal. It had the hood and the 3-foot diameter background as well. I built a little dolly, this sucker weighs almost 100 pounds, and wired it up and checked it out. Now, 20 years later, I decided to set it up outdoors, to annoy my wife, of course. My file of US&S instruction books and pamphlets were most helpful in completing this project. This is the signal mechanism itself, a true work of mid-century pre-digital engineering. Designed for fail-safe operation, it is basically a big electromagnetic relay. It operates on 12 volts DC, supplied by line-side batteries under continuous trickle charge from commercial power. Obviously, there is no power connected, but you can easily see the red aspect showing through the opening. 3 filters, or roundels, were made for US&S by the Eastman Kodak Company's Rattan Filter Division. They are mounted on a vane that moves back and forth depending on which way the relay is energized. Absence of power to the mechanism causes the unit to be in the resting position. This is a fail-safe condition in case of circuit loss. The many terminals are used to send and receive commands to and from the field location back to the office via the code lines on the poles. The lamp unit holds and precisely focuses the 25-watt bulb in a reflector. A rheostat on the rear is used to adjust the voltage to about 10 volts for conserving bulb life. General Electric manufactured a special bulb for US&S that had 2 filaments. In case one burned out, the other would step in. A complicated system of concave lenses and a prism concentrated the beam down the track. This unit, as was Santa Fe standard practice, is equipped with a fan kill attachment on the front to help reduce phantom aspects caused by sunlight entering from the front. I bought a Chinesium 12-volt power supply to run the unit and wired a double-pole, double-throw toggle switch between the power supply and the mechanism. This enabled me to check out the signal after 20 years of storage. It worked perfectly. Watch as the filter vane moves back and forth due to the change in polarity. Kinda cool, huh? As the aspect timer for this unit would be located outdoors in a US&S enclosure, I wanted to try and keep it as simple and rugged as possible. Therefore, I did not want to use any kind of digital electronic timer to switch the aspects. I came up with an electro-mechanical timer using a 5 RPM DC motor with a 16:1 gear reduction drive that turns 2 timing discs that operate a pair of micro switches. These switches are connected to double pole double throw relays to switch the polarity to the signal mechanism. Using simple math, I calculated the diameter of the discs and depressions for the wheels on the micro switches and built a wood mock-up. With just a few adjustments, it worked perfectly. The discs rotate at 1/3 of an RPM. Aligned on the drive shaft at 240 degrees apart gives me about a minute between aspects. I then built the production model out of aluminum. The discs were cut from 1/4-inch acrylic on my CNC machine. The spur and worm reduction gears came from eBay, and I made all the other parts in my machine shop. The timer and power supply were installed in a US&S all-weather cable box that will mount at the bottom of the mast. The 120-volt AC power comes in at the bottom. Behind the mounting plate is a large hole where the wires come from the signal unit and down the inside of the mast. I located a piece of 4-inch pipe, which is 4.5 inches outside diameter, for the mast, but it took a lot of blacksmith work to make the brackets to hold the cable box to the mast. I also had to find a pair of big U-bolts to secure the signal mounting arm to the mast. They were 5/8 11 thread, but the threads were too short. I broke out the big old pipe threader, cut longer threads, and sawed off the excess. All the new parts and hardware were primed with cold galvanizing compound. The mast arrived from the sandblaster, and I gave it 2 coats of galvanizing spray, and then 2 coats of Rust-Oleum aluminum spray. A good friend came over and drilled a 10 by 48-inch hole for the mast. The most useless tools I own down here in rocky central Texas are a shovel and a post hole digger. Six bags of Saccrete later, the mast is planted. It's about 12 feet from the ground to the top of the mast. The prototype standard was 16 feet 6 inches, but I wanted it shorter so people could see the aspects a bit easier. As in most of my projects, good friends chip in to help. We let the concrete cure for several days before starting to mount the signal components. The forklift was a godsend.
You're in. There you are. Does that look like the right angle?
Yep.
Why is the thread smoothing?
Hurry. It's
No,
fine.
I'm not hurrying, I'm jiggling.
It's sitting on it now.
Yeah. It's just this thread. That last night.
Wait a second. We got.
It needs to go down. If you could push from the top, maybe. Lord, it's hard.
I think that's it.
Yeah, you can turn it. Is it on? Turn it down towards me.
Only 2 lengths of 16-gauge heavy-duty zip cord were required to make the signal and timer operate. 1 pair for the lamp and another pair for the timer.
Oh, is that what we need that for? Now these. Sorry. Oh, well.
Well.
Can you get that? I can print more of them. Well, he can hand it to me when we put it in there real quick. I didn't know he could do that. Now he's going to give me a time slip for that.
Are there multiple of those?
He doesn't like to do that. Bend down.
Just a little touch-up paint and it's fully operational. Gee, I wish I had a Santa Fe finial to put on the top of this guy. Please hit that old like button. Comments are always welcome, so please do. And thanks very much for watching.